To solve a rational equation, the first thing you want to do is identify any values that might make your denominator 0. Look and see where your variables are. So in this case, we see a 4z and a 6z. So our variable is just a z by itself multiplied by a constant. In this case, the values that would make either 4z 0 or 6z 0 would simply just be 0, because when we solve, dividing by 4 gives us 0, dividing by 6 gives us 0. So the one value that this particular equation is undefined for would be z equals 0. So we're going to make a note, and we're going to say that z could not equal to 0. The reason that we have to do this when we're solving, we know that fractions are undefined if the denominators are 0. And so anytime you're solving an equation that has a fraction in it that specifically has the variable in the denominator, any parts and pieces that have the variable equal to the denominator needs to be set to 0 so that you can make a note of what values are not legitimate in your equation. Now that we've determined that, we need to find the LCD for the equation. The LCD, or least common denominator, is the smallest value that each one of the denominators will go into. What I do here is I separate and I think about my numbers first and then my variables. So if we think about the numbers 3, 4, and 6, then the LCD between 3, 4, and 6 is 12. Then with the variables, when I have variables that are just multiplied like these, then I would basically take the largest power of the variable that I have. Well, both of these are understood z to the firsts, so I would just take z. So 12z is my LCD. I'm going to put it over 1, and then what I'll start my problem by doing is multiply each one of these 4 terms by 12z over 1, and what that will accomplish is it will clear my fractions. So I'll take this equation, 12z over 1 times 1/3 minus 12z over 1 times 7 over 4z equals 12z over 1 times 1/4 minus 12z over 1 times 1 over 6z. Now go back and cancel. So 3 into 12 goes 4 times. 4z times 1 would be left over, so that's just 4z, minus 4 into 12 goes 3 times. Notice here the z's also cancel, so I'm left with 3 times 7, so 21 equals, cancel the 4 and the 12, that goes 3 times. There's a 3z times 1 left over, so 3z, minus 6 into 12 goes twice. Also notice these z's cancel, so minus 2 times 1, which is just minus 2. Now we have a simple equation to solve. So subtract over the 3z. That will leave me with z minus 21 equals negative 2. Add over the 21, and we end up getting z equals 19. Now you want to double check your solution and make sure that this solution is not one of the values that you said you could not have z being equal. So if we take this back down, notice that this particular solution is okay because it's not 0, which was the one thing that we said that z could not equal.